So today's webinar entitled Cathedral Ceiling Assemblies, and that's really what we're going to work through today. Multiple different fronts on that. And here's the AIA information. As I had mentioned, it is accredited for 1 LUHSW. So cathedral ceiling assemblies, or as oftenly referred to in the code, ceilings without attics, are not a new concept in residential designs. However, with the increase in energy efficiency and the tighter tolerances for moisture and air infiltration, um, we need to have a dedicated design for these assemblies, and not just a dedicated design, but we need to be really specific in the materials being offered in this assembly to make sure that the specifications are doing exactly as we intend, right? So if we're looking for something that has to have some sort of a low moisture permeance, we want to make sure that the products are indeed providing that low moisture permeability. If we need something that, on the flip side, we're looking for in the design to have a high moisture permeance, we indeed need to make sure that a product is chosen for that. So throughout this presentation, these are the couple things that I'm going to try to relay to you folks. Number one here is understanding what what ceilings without attic spaces are per the definition in the 2018 IRC. And not that the IRC specifically has a definition for attics without spaces, but we want to really understand what that assembly is. Next, we're going to review the 2018 IRC prescriptive designs for ceilings without attic spaces. In particular, we're going to look at ceilings without attic spaces with an unvented assembly. The code kind of gives out 4 really good examples, and we're going to look in depth in 2 of those, or for 2 of those. We're going to examine how the lack of attention to detail can lead to an increased risk in assemblies. And beyond that, lack of attention to detail, and also if we're looking at products that don't meet the intent of what the code is prescribing, and there's one specific example that I'm going to look at that with low density or open cell spray foam, and that could increase the risk of susceptibility to early decay of those building materials, again in regards to moisture. And finally here, just working through the learning objectives, we're going to review key details that can increase the longevity of ceilings without attic space assemblies, which can provide energy efficient assembly for the end user, right? We're going to look at, again, not all designs are for everybody. So luckily the code really does kind of lay out 4 different designs for specific unvented attic assemblies. And that's really what I'm looking at here. And it'd be great for end users or for designers and builders to choose a design and an assembly that works best for everyone. All right, so question did come in. I'm just going to answer that now. Why not the 2021 IRC? The reason for that is here in Pennsylvania, we adopt a code cycle behind. So we're currently under the 2018. So we're really going to look at the climate zone specifically addressed within Pennsylvania in this webinar. So a couple things to go beyond what the learning objectives state. We're going to look at what are the R values in Pennsylvania in regards to the attic R values, and that can change based on the assembly. So bullet point number 2 here is, take a look at how these R values can change as we look at what's in the insulation and fenestration table, and then how that could change depending on what type of assembly we're going to be using in these attic areas. We're going to explain venting concerns with cathedral ceiling assemblies and ceilings without attics. We'll walk through some prescriptive requirements, and then finally we're going to look at some prescriptive designs for both vented and unvented. I have some examples for both assemblies. But we have to start somewhere. And the place that I would like to start today is looking at the provisions, obviously, in Chapter 11, which is the energy chapter in the IRC, and then it's also gonna run concurrent with the energy provisions out of Chapter 4 in the IECC. And then at the very end, we're going to tie in a provision out of the 2021 Pennsylvania alternative. Now, if you're not familiar with the Pennsylvania alternative, you might be looking at that and be like, Chris, you just said that we're not under the 2021 IRC, we're under the 2018 IRC, and that is correct. The 2021 PA alt, the name is based on the year of development, but what you probably can't see here in the very bottom of this cover of the Pennsylvania alternative is that it does state that it is based on the 2018 IRC and IECC. So the 2021 is simply the date in which it was developed, but it is based on the 2018 IRC. We're going to again look at the three different climactic zones within Pennsylvania. That includes 4, 5, and 6. And the overwhelming majority of Pennsylvania falls within 5 and 6. We do have some counties down here in the southeastern portion of Pennsylvania that are within climate zone 4. But one thing I kind of want to address now is that, you know, there are provisions in the IRC that I'm going to touch on today that say for these specific climate zones, you're allowed to do this, but you can't do it in this climate zone, okay? But climate zones don't understand county boundaries, right? So, you know, just because York County right here is climate zone 4 doesn't mean that, you know, we have some overlap. And so a lot of the designs and risks that I'm going to address here, maybe a little bit later on, again, granted, you may be in climate zone 4, but that doesn't mean that you shouldn't at least look at and you know, calculate those risks within your assemblies that you plan to design. So again, these climactic zones haven't changed in quite some time. So if you're in 5, if you're in 5 in 2015, you're still in climate zone 5. But again, keep in mind which climate zone you're currently in and what you designed for what we're going to address here today. Looking at table N1102.1.2, which is the insulation and fenestration requirements by component. This table, again, is right out of the 2018 IRC. And as you can see here, for climate zones 4, 5, and 6, where we are here in Pennsylvania, our attic insulation or our ceiling R value is R49 for all 3 climate zones within Pennsylvania. But to take this one step further, we have N1102, and I'm going to say right now, there are a lot of code references in this webinar. Again, it's something that it's not always fun to work through, but it's a necessity. We have to make sure that we work through these code requirements, and a lot of these build on top of one another. For instance, this one right here, you know, where, you know, we first looked at this insulation and fenestration table N1102.1.2. You jump to this next N1102.2, and it talks about specific insulation requirements. So it takes it one step further, and it states that in addition to the requirements of N1102.1, insulation shall meet specific requirements of sections N1102.2.1 through point 13. And what I'm really going to talk about here today is, you know, really going to stop at these 3. We're going to look at N1102.2.1, which is ceilings with attic spaces. And then we're going to look at point 2, which is ceilings without attic spaces. And then we're finally going to look, not finally, but we're also going to address point 3 in this section, which addresses eave baffles and where they must be located. One thing that I didn't mention during the beginning portion of this is if you're looking for the handouts to today's presentation, you can find them on our website, phrc.psu.edu, and then you can drill down through the webinar portion, and then you can download those handouts. So if we're to look at the prescriptive R values of our insulation in our climate zones, we start with this umbrella of the N1102.1.2, which again is the insulation and fenestration table that says your overarching in those climate zones for your ceiling R values is R49. But not all attics, not all ceilings, not all spaces or roof ceiling assemblies are created equal, right? So what happens if we have additional designs? The code addresses this, right? So now we have N1102.2.1, not to be confused with the table up above. This discusses ceilings with attic spaces, and in climate zones 4, 5, and 6, remember we start with R49, and in our climate zones, under this provision, we have the potential to reduce that attic insulation from R49 to R38, and I'll walk through how this reduction, potential reduction, can happen here in a moment. The next step here is N1102.2.2, which is ceilings without attic spaces. And now we have an additional potential reduction. So we start with R49. Depending on the design and how we move forward, we have the potential to reduce it to R38. Now we have a different design, which now gives us the potential reduction to reduce that to R30. And again, our climactic zones 4, 5, and 6 here in Pennsylvania. So again, you have to start at the top of the umbrella, which is our insulation and fenestration table at R49, and then you can take those steps for potential reductions in R value in these provisions based on these sections. And we'll dive into that a little bit deeper. But before we move any further, I feel that it's important to really look at the definition of what is an attic. So luckily, the 2018 IRC has a specific definition for attic, and that is defined as the unfinished space between the ceiling assembly and the roof assembly, right? So if we're to, kind of look at those two different scenarios, you have your ceiling assembly, which is usually on the horizontal, right? Your ceilings are usually on the horizontal unless it's a cathedral. And then you have the roof assembly, which is usually at your angle of view. So that space in between there is defined as your attic. The commentary goes a little bit further and explains that an attic is the unfinished space between the ceiling joist of the top story and the roof rafters. So it gives you a better understanding of what we're talking about here. Your ceiling joist, which can be but are not always on the horizontal, and then your top story of the top story, and then you have your roof rafters. So in between that space, or those two products, it would be your attic. So let's move into what a vented ceiling assembly is, and how do you work through that. So we have a couple code provisions here for vented attics. We have 806.1, which is the ventilation is required. You have to ventilate that. And then you have 806.2, which is the minimum vent area. If you're interested in that, I'm not going to cover that in today's webinar, but you can look at Brian Wolfgang did a webinar last year, or our last webinar series, I should say, entitled Attic Ventilation, Understanding the Why. So you can go ahead and check that out on our website. It is recorded, so you can take a look at that if you are interested in understanding how to figure out what that minimum vent is for attics. And then 806.3, vent and insulation clearances, which I will talk about here today. So again, we're in the ventilated section here. 806.1 is ventilation is required, and then 806.3 talks about the ventilation, how to vent, and the insulation clearances. So 806.1, as I just mentioned, is ventilation required, and that states that for enclosed attics and enclosed rafter assembly spaces, or enclosed rafter spaces formed where ceilings are applied directly to the underside of the roof rafters, shall have cross ventilation for each separate space by ventilated openings protected against entrance from rain or snow. So what this is talking about here is not only are enclosed attics that are comprised of ceiling joist and rafters, we also have enclosed rafter spaces formed where the ceilings are applied directly to the underside of the roof rafters. They also have to have cross ventilation, right? So you can imagine what that may look like when you have a roof system designed and constructed with a 2x12. When you have that ceiling applied directly to the underside of the roof rafter, that space also still has to be cross-ventilated per 806.1. So this is typically what you're going to be thinking of. This is our ventilation for ceilings with attic spaces, where we're entering through the eave. We're continuing up above the eave baffle, which we'll touch on in a second, and then we are exiting that ventilation through our ridge vent. So where eave or cornice vents are installed, blocking, bridging, and insulation shall not block the free flow. And then it says not less than 1 inch of space shall be provided between the insulation and the roof sheathing at the location from the location of the vent to the vent out through the top. So jumping back to this slide here, that's why I have eave baffle specifically being called out in this location right here, because we have insulation being compressed up against the underside of the roof sheathing, and the provision that I just read states that you have to ensure that you have that ventilation happening between the insulation and the roof sheathing. So one step further, here we have eave baffles. Remember, I said we're going to talk about N1102.2.1, 2, and 3. Here is the eave baffles falling in under point 3. That says, for air permeable insulation in vented attics, a baffle shall be installed adjacent to the soffit and eave vents. Baffles shall maintain the opening equal to or greater than the size of the vent. And then again here in red, the baffle shall extend over the top of the attic insulation, and the baffle shall be permitted to be made of any solid material. So I want to take a look at 2 different products, right? The code says that we have to make sure that we have at least 1 inch of a ventilation between the insulation and the underside of that roof sheathing. But when you look at some products, they come in multiple different sizes. This one here, as shown in boxed out here, is a product from Home Depot. It's a Merrimax home product that says that it has 1.5 inches in depth, right? So from the underside of the roof sheathing to the other side of the baffle, your clearance is going to be 1.5 inches. Now this product here, this is an Owens Corning product. Again, purchased through Home Depot, or has the potential to be purchased through Home Depot. These products are easy to find, both of these out of one location. However, when looking through the dimensions or the specifications of these products, this one here is 2.5 inches. And you might be saying, well, Chris, it's a difference of 1 inch, right? When you're talking about venting an attic, does that make a difference? Well, when your attic assembly is of this nature here, where you have a true attic space. This is a ceiling with attic, and your blown insulation is being applied, and you're creating your baffles here over on the side. Does that compression necessarily matter at that point? I would say at first glance, probably not. However, there are going to be assemblies, and I'm going to look at 2 different approaches where that clearance does matter, and it matters quite a bit. So N1102.1, I'm sorry, N1102.2.1, this is ceilings with attic spaces, okay? The first portion of this states that when N11, or this is R1102.1.2, which is the insulation and fenestration table, requires R38 in the ceiling. That's not us, right? That's not in Pennsylvania, as we saw earlier. All of Pennsylvania requires R49 as our starting point for attic insulation. So let's jump down to the second half of this provision, where it says that section N1102.2 N1102.1.2 requires R49 insulation in the ceiling. That's where we are. Installing R38 insulation over 100% of the ceiling area requiring insulation shall satisfy the requirement of R49. Wherever the full height uncompressed R38 insulation extends over the wall top plate at the eaves. So I'll show a picture of what that'll look like in a second here. But if we're to look at this slide here, this is the Insulation Institute, and this graph depicts different types of insulation, different R values. They're labeled thickness. Now, I understand that you might be able to get different R values in different thicknesses, but for the purpose of what I'm going to show here, we're going to assume that R49 is 14 inches, okay? When you compress that to, let's say, 11 7/8, so 12 inches for an 11 7/8 eye joist, that reduction takes it down to R44. Looking at a 2x12, which is 11 1/4 inches, that 14-inch insulation R49 is reduced down to R42. It's stating that when you compress insulation, you're reducing the effective R value of that insulation. So if we're to look back at, some of those pictures that I showed previously, where we have that insulation being compressed out at the eaves, we're not getting full depth R38 to the exterior. That's why you have to have R49. This provision here is allowing you to reduce your R49 insulation to R38, provided you can get a R38 all over the entire floor, all the way to the exterior side of the exterior wall. Again, this is potentially our standard attic ventilation, where we're compressing our insulation out here over the eaves. What this is allowing is, if we do a 14-inch raised heel truss, an energy heel that allows for full depth R38, now we can take that reduction. But that's not why we're here today. Why we're here today is to talk about ceilings without attic spaces. The reason I didn't start right into these provisions is because we needed a starting point based on the code. And that starting point is an R49 for a standard attic, or standard ceiling with attic spaces. From that point, you have to build, and you can come down to 1102.2.2, which is ceilings without attic spaces. And what this states here is that where N1102.2.1, which is the provision that we just looked at, that says that you can reduce from R48 to R49 to R38 without compression, you can do that. But what this provision says is that where that rule requires insulation greater than R30 in the ceiling, and that ceiling assembly does not allow for sufficient space for the required insulation, the minimum required insulation R value for such roof ceiling assemblies shall be reduced to R30. So we started at R49. We had a potential reduction to R38. Now we're looking at a different assembly that's greater than R30. Now we can reduce it to R30 when our roof ceiling assemblies don't allow for anything greater than R30. One of the big things that I want to make sure that we do address here is that insulation shall extend over the top of the wall plate to the outer edge of such plate and shall not be compressed. That R30 shall not be compressed. So again, here we are, N1102.2.1, ceilings without attic spaces can be reduced to R38, and here's exactly what I just worked through. That reduction can now be reduced to R30 as long as if the roof ceiling assembly does not allow for anything greater. So the first example that I kind of want to take a look at here today is just our standard rafter design. For those of you out there who have seen a raftered ceiling before, this is typically what you're going to see: a 2x12 rafter, probably bad insulation, called out R30. And again, this is a vented assembly. So we have to make sure that we have our eave baffles in those locations. So to look at some dimensions here, we have a 2x12, which is 11.25 inches. If we're going to look at eave baffles, we saw a product earlier, 2.5-inch thick eave baffle. That allows for an insulation clearance of 8.75 inches. Right? So as I said, it's a vented assembly, so we have to maintain that minimum 1-inch ventilation from the intake to the exhaust. Therefore, that eave baffle must run the entire length of that rafter. So 8.75 inches. And here we are looking at this table again, estimated R values for insulation compressed into framing cavities. Here we have the R30, which can come in two different thicknesses. You have a 10-inch or 9.5-inch, but either which way, both of those are less than 8.75 inches. So if we're to take a look at this table here, R30, 10, 9.5, and we're somewhere in between R25 and R30 when looking at compressing that R30 insulation into the 8.75-inch space. Now, two things are wrong here. Number one is, you know, the code specifically says that that R30 must be installed without compression. And when you look at the compression of that R30, that takes you dramatically below the required R value, effectively reducing it to somewhere in between R25 and probably R29, definitely below R30. So if we look at the same assembly and we change one thing, right? Our 2x12 is still 11 1/4 inches in nominal thickness. The eave baffle is the one we're going to change. As the two examples that I showed earlier, one was 2.5 inches and the other one was 1.5 inches. So by simply changing out the product to another qualified baffle to 1.5 inches, we now have an insulation clearance of 7 3/4. As long as the insulation spec for this product or this project is a 9.5 inch loft, we are able to use this rafter assembly and install the R30 insulation without any compression. So, the last bullet point here, really calls out for that eave baffle specification matters. It's not as simple as assuming that you could call out for an eave baffle and the correct one's going to show up on site. When tolerances are as tight as they are, for ensuring that our insulation is not compressed, then specific care has to be taken into consideration when calling out for eave baffles, and the maximum thickness of what they can be. So the second assembly that I want to quickly take a look at here is still a raftered ceiling assembly. It's still a vented ceiling assembly, but what we're doing is we're adding 2x4s to the bottom of the 2x12s, being used as rafters, your structural components of this roof ceiling assembly. Now, these 2x4s have to be attached with some sort of a gusset. Could be a plywood gusset, but either which way, they have to be firmly attached to carry the loading of the ceiling covering, whether it be drywall or whatever it might be. But either which way, what we have going on here is our 2x12 that's still 11 1/4 inches thick or deep, and then we have an additional 3.5 inches provided by the 2x4, an eave baffle of 2.5 inches. So now we're looking at the larger side of our eave baffle specifications. So now we have an insulation clearance of 11 1/4 inches. This gives us the ability to not only meet the R30 requirement, but we have the potential now to install something of a greater R value, or R38 at this point, which is 12 inches, slightly compressed, but again, we're above our R30, so that slight compression should be accepted. This example here is a little bit outside of the box. This originally came from where I saw it first, which was a fine home building document. This includes a 2x12 rafter. Again, it's still 11 1/4 inches. Our insulation clearance in total is 11 1/4 because we're installing a 2x4 on top of the 2x12 rafter. Okay, the next slide that I have shows a picture of what this will look like in case there's any sort of confusion. But as you can see here, still raftered, still vented assembly, and I'm calling out for a high perm barrier between the rafter and the 2x4. So this high perm barrier between the insulation and our vent space is to allow any sort of high moisture air to escape from that area. We want that to diffuse through that high perm barrier, and then be vented out through the vented assembly through the ridge. So this is an example, or a picture of what this may look like. Over here on the left-hand side, that's our 2x12 rafter. This is a high perm, very high perm barrier. I believe this product that they are using in this YouTube video actually is a commercial grade house wrap with, again, a very high perm rating, and that's installed directly over top of the 2x12. And then as you can see here, our 2x4s are nailed on top of that. That is creating an 1.5 inch deep air chase completely up through to vent this ceiling assembly. The other thing that this barrier here does is it keeps, depending on the type of insulation, it could be batt material that's being installed below. With this type of material, you can also use blown in dense packed cellulose if you're putting some sort of a netting on the other side, or a smart vapor retarder, whatever it may be, on the bottom side of these rafters. So again, one thing that I do want to touch on, I was walking through this assembly with an engineer friend of mine, and he'd pointed out that an engineer may have to get involved slightly on this to kind of calculate this connection of the roof sheathing to or through that 2x4 into the rafter, because that roof sheathing isn't being applied directly on top of the rafter. There may be some sort of engineering that has to be taken place for this assembly to continue on, but it does allow for, I would call it a great way to vent this raftered truss or raftered ceiling. Speaking of trusses, your ceilings without attic spaces don't have to be, or are not limited to, nominal dimensional rafters. Truss manufacturers anymore, boy, they can really come up with some ingenious designs. And this one here is just a parallel cord truss. This isn't a cathedral. This is a vaulted scenario here where we have a story and a half over a family room potentially, but we want to make sure that we have that high steep pitch or slope for a ceiling assembly, and you can create that with a parallel cord truss. So in following with the provisions of the IRC, you could, in essence, do a 12-inch heel and install R30 in the ceilings without attic space up through, but you're not limited to that, right? If they're going to trust this, you could go with an 18-inch heel and install R38 insulation in that attic ceiling without attic space. But you don't have to stop there either. You jump to a 24-inch heel, and you can get full depth R49 insulation over this entire area. Now, one thing that I will point out is that although this assembly works fantastic for insulation, it may present a different view architecturally when looking out here. Our clearance between our windows and our fascia are now going to grow depending on what that heel height is, right? So you may have to take into consideration some alternative architectural design methods when looking at it from the outside, whether it's, different design features above the windows, whatever it may be, that does have the potential to change. So unvented ceiling assemblies, a little bit of, not necessarily difficult, but it's not used as often. It's not used very often. Therefore, working through this can be a little bit tricky. But I'm going to try to work through this the best that I can. And again, if you have any questions, please feel free to ask them. It'd be greatly appreciated. These are going to come out of the unvented portion in R 806.5, which is unvented attic and unvented enclosed rafter assemblies. And that is laid out right here that states that unvented attics and unvented enclosed roof framing assemblies created by ceilings that are applied directly to the underside of the roof framing members and structural roof sheathing applied directly to the top of the roof framing members or rafters shall be permitted where all of the following conditions are met. So there's a lot to unpack right there, right? So really what we're talking about is a sandwich. And this sandwich is going to be comprised of our roof sheathing is one slice of the bread. And then we have the meat filling, which is our rafter and our insulation. And then the other side of our sandwich is going to be our ceiling assembly, or our ceiling, which would be drywall, for instance. So we're talking about that sandwich here. all pulled together over that roof framing member. And again, shall be permitted where all of the following conditions are met. Initially, we're going to look at 1 through 4. When we get to 5, it breaks out into multiple subpoints. But really, number 1 here is, again, we're allowed to have an unvented attic and an unvented enclosed rafter assembly, provided that the unvented attic space is completely within the building thermal envelope. So we're going from, this is our may not be typical for everybody, but looking at the industry as a whole, our insulation is across our ceiling area. So we're taking that insulation and we're taking that thermal boundary from this location to this location. We're now at the underside of our roof deck. And again, I know we're talking about ceilings without attic spaces right here. But what's being shown here is again, it's an attic, but it's now an unvented attic. Number 2, interior class 1 vapor retarders are not installed on the ceiling side of the unvented attic assembly or on the ceiling side of an unvented enclosed roof framing assembly. Again, that unvented enclosed roof framing assembly is a ceiling without an attic space. So we cannot have a class 1 vapor retarder on the ceiling side of that assembly. Number 3, where wood shingles or shakes are used, a minimum of 1/4 inch vented airspace separates the shingles from the roof underlayment. And then number 4 here, in climate zones 5 and 6, okay, the overwhelming majority of Pennsylvania is in climate zones 5 and 6. I will touch on climate zones 4 in a little bit, and how, as I said at the very beginning of my presentation, climate zones don't understand county boundaries. So just because you're in climate zone 4 doesn't mean that you should completely ignore this. It just means that this provision does not apply specific. So in climate zones 5 and 6, 7 and 8 as well, any air impermeable insulation shall be a class 2 vapor retarder or shall have a class 2 vapor retarder coating or covering in direct contact with the underside of the insulation. So again, there's a whole lot to unpack there as well. Air impermeable insulation, closed cell spray foam, open cell spray foam, rigid board, they're air impermeable insulation. However, it shall be a class 2 vapor retarder, and if it's not a class 2 vapor retarder, you have to apply coating that is a class 2 vapor retarder directly in contact with the underside of the insulation. It's critical when we move forward here. So we just talked about 1 through 4, right? It has to follow all of those, and it also has to meet 5, where it says insulation shall comply with item 5.3 and either 5.1 or 5.2. So again, I'm going to break this down again a little bit. 5.3 is specific to preformed insulation boards, and we're going to talk about that in a second. And either 5.1 or 5.2, what you have being shown in front of you is 5.1. We're going to work through this. 5.2 being shown here is only for climate zones 1, 2, and 3. So we don't have to look at 5.2. So insulation shall comply with 5.3, and in our case here in Pennsylvania, 5.1. So working through this, 5.1 through 4 shall be met depending on the air permeability of the insulation in direct contact with the underside of the structural wood sheathing. So example 1 here, which is 5.1.1, talks about where only air impermeable insulation is provided, it shall be applied in direct contact with the underside of the roof structural sheathing, right? Point 2 is where air permeable insulation is installed directly below the structural sheathing. Rigid board or sheet insulation shall be installed directly above the structural roof sheathing in accordance with the R values in 806.5 for condensation control. And we'll look at 806.5 here in a little bit, but just to give you a quick understanding of what that table is, that table specifies the minimum air impermeable insulation that has to be used based on climate zones. And we'll talk about that. And 5.1.3, where both air impermeable and air permeable insulations are provided, the air impermeable insulation shall be applied in direct contact with the underside of the structural roof sheathing in accordance with 5.1, and shall be in accordance with the tables in table 8.6.5 for condensation control, and then the air impermeable insulation shall be installed directly under that air impermeable insulation. Now, so looking at 5.1.1, that is specific to only air impermeable. Looking at 5.1.2, that's air impermeable with rigid or some type of rigid insulation applied to the top side of the wood structural sheathing for the roof. 5.1.3 is a combination of air permeable and air impermeable insulation, and I'm going to show examples of these. And then 5.1.4 is really a calculation method that says, alternatively, sufficient rigid board insulation or sheet insulation shall be installed directly above the roof structural sheathing to maintain a monthly average temperature of the underside of the structural roof sheathing of 45 degrees Fahrenheit. Again, we're not going to get into that one. That's a calculated one based on your climactic zone. So again, 5.2, we don't have to worry about it because that's outside of the climate zones within Pennsylvania. And example number 1 that I'm going to look at is part 5.1.1, which is specifically air impermeable insulation only. And what I want to point at here is this note calls out for R49 closed cell spray foam insulation is the insulation that I'm calling out in this example. So again, here's the text of the code that says 5.1.1, where air impermeable, only air impermeable insulation is provided, it shall be applied in direct contact with the underside of the structural roof sheathing. The example that I showed, there it is again, it is in direct contact with the underside of the roof structural sheathing. So we can check that off the list. We also have to follow, again, part 4 that says in climate zones 5 and 6, any air impermeable insulation shall be a class 2 vapor retarder or shall have a class 2 vapor retarder coating or covering in direct contact with the underside of that insulation. I told you we would come back to that. And the reason for that is I'm going to look at 2 buildingscience.com articles, both addressing this situation and why the code references that, and why just because you're outside or across that county border, why you should disregard this risk, okay? So this comes from a residential spray foam guide from Building Science Corporation, and these references, the links to these references can be found in the references slide at the end of this presentation. So if you want to find these, download the handouts and you can download these documents. But this document says that unvented conditioned attics can be constructed by installing low density open cell or high density closed cell spray foam and directly to the underside of the roof deck, which is shown in this figure here on the screen. Both foam types work in most climates. However, in IECC climate zones 5 and higher, only high density closed cell spray foam shall be used. Now that runs concurrent with what we just read out of the IRC, right? That runs concurrent with what's here in number 4, climate zones 5 and 6, air impermeable insulation shall be class 2 vapor retarder, so on and so forth. Because open cell spray foam is not a class 2 vapor retarder. Well, Chris, what does that mean? Well, if you look at, this is paragraph 8 out of another building science document. In this one, I didn't name it, but the name of this document is Dirty Harry Does Insulation. And it specifically talks about when you spray open cell spray foam into wall cavities from the interior, the open cell spray foam can act as air control layer and thermal control layer. It cannot act as a vapor control layer. It's too vapor open. So this is a problem when you spray open cell spray foam to the underside of roof and attic assemblies. You can end up with problems, ping pong water. And this is what that means, right? So when you have an open cell spray foam that's vapor open, right? It's not a class 2 vapor retarder, which is specified for 5 and 6. It's vapor open. So what that allows is for vapor to permeate through that open cell spray foam and getting absorbed into that roof sheathing. However, during the day, that moisture is then driven out through solar radiation. And that's what's causing, as Joe Stiebert called it, the ping pong effect, where we have water vapor permeating the open cell spray foam, being absorbed into that roof sheathing. Then during the day, it's driven back out into that attic assembly, or it doesn't have to be attic. It could be we could have drywall in this location. So it's driven to the drywall and then again pushed back in the evening, creating a ping pong effect, and then you have a condensation of not a condensation, but you have all of this insulation being condensed into the ridge area, which then can lead to moisture concerns. So the only way to get rid of that moisture, because it's unvented attic, is through a dehumidifier or return to the house. But again, if this is a ceiling without attic space, you can't install air supplies in those locations. So again, as Joe Stieber called it, it's the ping pong effect where we have that moisture rising to the ridge. So the second option that I'm going to show in regards to an unvented attic assembly is part 5.1.3, which is the combination of both air permeable and air impermeable insulation, right? So this example is being shown with 6 inches, 3 layers of 2-inch rigid foam XPS, which gets you an R30 insulation, and then you add air permeable insulation underneath of that. This is done with a 2x12 rafter, which gives you a total of roughly an R50 for this attic assembly, or this cathedral ceiling assembly. So we always want to make sure that we work through the text on how to get to those assembly. So if we're to look at, again, coming out of 806.5, Part 5 says that insulation shall comply with 5.3 and 5.1 in the Pennsylvania climate zones. 5.3, I'm going to jump down here to the bottom, which we have not yet addressed. It states that where preformed insulation board is used as the air impermeable insulation layer, it shall be sealed at the perimeter of each individual sheet at the interior surface to form a continuous layer. So this is the assembly that I'm using as an example, right? Where we're using multiple layers of rigid preformed board that you're cutting to then fit in between those rafters. That's what we're talking about here. So each one of those layers that's being installed, each one of these layers that's being installed has to then be air sealed, right? We want to make sure that we don't have any air movement that could carry moisture permeate through this and come in contact with the underside of that roof sheathing. That's why 5.3 comes into play here. But we also have to look at 5.1.3 that states where both air impermeable and air permeable insulation are provided, the air impermeable insulation shall be applied in direct contact with the underside of the roof structural sheathing, which my example showed. The rigid board is installed to the underside of the roof structural sheathing, and shall be in accordance with the R values in table 806.5, which I'm going to look at. And then we'll also, the air permeable insulation shall be installed in direct contact underneath the air impermeable insulation. Again, that's what's being shown here in this example. But I quickly want to address a comment. Somebody had once said, can't you do, and I'm in quotes here, a flash and bat system here, right? I don't know if you're aware, a flash and bat in a wall assembly where someone would come in and spray a flash coat of like 2 inches of closed cell spray foam and then backfill that with bat insulation on top of that. Now, the code does not address that specifically. but it does indirectly address that with this table 806.5, which I've referenced multiple times through code reference. So what we're looking at here is our climate zone over here on the left-hand side. Again, we're in 4, 5, and 6 here in Pennsylvania. And then this tells us over here on the right-hand side, our minimum R value for rigid bore on air impermeable insulation, right? So for climate zone 5, I'm going to use as an example, we have to have a minimum R20 rigid board or air impermeable insulation being used in that location with a combination, right? Footnote 8 says that this contributes but does not supersede the requirements in N1102, which is the insulation and fenestration table, right? So this contributes to our needed R value, but does not supersede. So we can't just say, okay, I met the requirement of the R value in 806.5, I can stop, right? We can't stop there. We have to still meet the requirements listed out in section N1102, which is our insulation and fenestration table. So again, to jump back to my example here, this is the combination air impermeable, air permeable. We meet the intent of the table as we have R30 impermeable insulation. So we're greater than, as I called, or as I stated, R20 in climate zone 5. So then we back that with bad insulation or air permeable insulation to create our total assembly as listed in part 5.1.3 out of the IRC. Again, a flash and bat, I'm cautious to say that it could work. You just have to make sure that that flash, we're going to call it, that air impermeable insulation is greater than or equal to the required R value in table 806.5. I hope that came across coherently there. Finally, the last thing that I want to touch on here today as we hit 2 o'clock is our maximum area, right? So our maximum area in the IRC is limited to, this is again, ceilings without attic spaces, limited to 500 square feet or 20% of the total insulated ceiling area. So if we're looking at, let's say, a ranch with lots of ceilings without attic spaces, right? We're talking about that sandwich, not attics. We're talking about that sandwich with roof sheathing, raftered assembly, or parallel cord truss with insulation, and then our drywalled ceiling. We're limited to 500 square feet or 20% of the total insulated ceiling area, whichever is less. And this is where I'm going to bring in the Pennsylvania alternative. Again, this is specific to Pennsylvania, so if anybody's watching here outside of Pennsylvania, unfortunately, this does not apply, or you can't use this, but for those of us who are in Pennsylvania, we can use the PA alternative in this location, and this is where the entrance requirement, and to enter the Pennsylvania alternative, it's a trade-off program where you have to meet one of these entrance requirements. So one option, you have to choose one of these. And once you meet that, you get all of the trade-offs on the back side of this. For this example, I'm going to say it has to be new construction, and the project that we're using is in climate zone 5, or the central climate zone, and I'm going to use number 5 option, which is improved efficiency condensing furnace installed, and it's greater than a 95 AFUE. So that satisfies my one entrance requirement. So then we can go to any of our trade-offs, and one of the trade-offs within the Pennsylvania alternative is in regards to ceiling, cathedral ceilings or ceilings without attic spaces, and it's the R30 insulation for up to 75% of the total living space square footage. So if you remember, the IRC, you're limited to 500 square feet or 20% of the total insulated ceiling area, whichever is less. The Pennsylvania alternative allows for 75% of the total living space square footage. So what that means is if we have a ranch on a slab, up to 75% of that ceiling area can be cathedral ceiling or a ceiling without attic space. If we have a 2-story, 28 by 30 box, that means that you could potentially have your entire second floor all cathedral ceiling or ceiling without attic space. So this just increases the allowance for that. So if you have a design out there where you have greater than 500 square feet, you may have an opportunity to use the Pennsylvania alternative for that design. Again, if you download the handouts, this link here at the bottom is active in those handouts, or you can go ahead and click on that, or you can actually search in any search engine the 2021 PHRC Pennsylvania Alternative Residential Energy Provisions, and the link should be close to the top of that search result. So in summary, a couple things that I want to highlight here is be careful of insulation compression, right? Look at that entire assembly. Look at the thickness, the loft of your chosen insulation, and if that is compressed at any point, is that compression at all allowed? And if it's not, you need to take a look at that assembly, and either change your insulation or change your baffle or change your rafter. You know, if you're using a 2x10, maybe you have to go to 2x12 or jump outside of the box and go to an engineered product. This should be designed as an assembly, not constructed with individual components. And that ties into bullet point 1 here. You know, you can't compile that entire sandwich, I'm going to call it, whether it's vented or unvented, open to the lack of looking at that as an assembly, right? You can't just say, I want to use a 2x12 and I want to use some sort of a baffle and I want to use bad insulation, because that might not work. So you have to look at that entire assembly, not individual components within that assembly, outside of the grand scope. Know the specifications of your product. They're not all created equal, as shown in bullet point number 4 here, right? You know, not all insulation is created equal. Not all spray foam is created equal. Make sure that if you don't just call it spray foam insulation when you specifically need a closed cell or something that's a class 2 minimum vapor retarder, right? So not all spray foam is created equal. Make sure that the spray foam that you're anticipating being used, you specifically called out. If you're using a vented assembly, make sure that if the tolerances are tight, make sure that you're calling out the correct eave baffle or maximum thickness of that eave baffle. And then choose a lane and stick in it, right? If it's vented, vent it correctly. If it's unvented, air seal it correctly and make sure that you follow the vapor retarder requirements correctly. Okay. With that being said, I'm going to jump to the questions. Here is the resources. Again, we're looking at the 2 different Building Science Corporation documents that I addressed, and also building a vaulted high performance and foam-free roof assembly. That really addresses the vented assembly that has the 2x4 attached to the top of your rafter. So those 3 references, if you're interested in any of those, absolutely download the handouts, as these links are active.